Initial deposit of €3,000 is made in a savings account for which the interest is compounded continuously. So that means that every year you get 5% added on, added on, and added on. The amount A is found by the following formula, where the amount you have at the end equals your investment multiplied by E. E is the number 2.713. It's just a constant number, right? It's in your calculator, it's saved, okay? R is the rate of interest in decimal form. So for instance, if we had 5%, it would be R would be 0.05. It's in decimal form, not percentage form, okay? And then T is the amount of time in years. So we can see that it's 7 years, okay? Now, let's write down our question here, okay? So A equals A, we don't know what it is, but we're told that it doubles in 7 years. So what does that mean? What would A be after 7 years? 6,000, right? So A is 6,000 after 7 years. P is 3,000 principal. Okay. E, it's just safe in your calculator. We're looking for the rate of interest. So the whole point is to find out what R is, and T is 7. So it's going to be e to the power of 7 R. Now, there's something that you have to do every time in step 1. Okay, and I'm going to show you why. I'm going to show you step 1, and then I'm going to go back and explain why it is step 1. Okay, so you'll always take the number that comes in front of the exponential, and you'll always bring it under and divide into the other side, whether it goes in evenly or not. Leave the answer in fraction mode, okay? So we're then going to get 2 equals e to the power of 7r. We got to get r on its own. Now what's the problem with r at the moment? It's in the power position. We don't want it in the power position. There's a way to get rid of numbers in the power position. Okay, so what we do is we ln both sides, or we log base e both sides. Log base e2 equals log base e to the 7r. So I basically log both of them. Okay. Now we're going to use our log rules next. The 7r will go to the front. So we'll have 7r log e base e, and then we're going to have log e2. Now what's log e base e? 1. Or just get rid of it. Okay. It's 1. Then to get r on its own, we divide ln2 or log e2 to the base e by 2. So r therefore equals ln2, which is the same thing as this here, divided by 7. Then it's just a matter of going into the calculator and saying, alright, ln2, and then we'll divide it by 7, and our answer is 0.099. And what is 0.099 in percentage form? 100%, tens, units, so 9.9%. And that is your answer for the first one. Yeah, 9.9%. You can check your answer. The way to check your answer would be to put in premium is going to be 3,000, and then put E, and time is 7. So it's going to be 7 multiplied by 0.099. If that turns out to be 6,000, we're good. So it's actually a great question was asked there to go about checking your answer before you leave, especially if you have time in the test, okay? So we'll see the e to the power button there, and then we're going to have 7 brackets 0.099. I reckon we'll get very close to 6,000. 59999. Yes, Connor?
Can you bring it up?
Oh yes, you're right. Anybody have that tick book there? The one we always... Okay. Population P, the current population, is modelled on P equals 12,300 multiplied by E by 0.73 T. T is time in years. After how many years, correct to one decimal place, will the population reach 20,000 people, provided it keeps growing in the same fashion? Replace P with 20,000. Okay. That equals 12,300 e to the 0.073 t. What is the point of the question? How many years? That means I need to get t equals something. T has to be isolated out, okay? Now, What I need to do first and foremost, if I log both sides right away, what's the problem? I said I'd introduce the problem here, okay? If I logged or ln'd both sides, what would happen? Am I allowed, and there's a reason for this, am I allowed to bring this to the front?
No, because it's a T.
No, not because it's a T. It's because, go for it.
It's already 12,100.
The problem is, this power is only a power to the E part. Do you understand? The power only belongs to the E part. So, just bear with me for 1 second. It only belongs to the E part, okay? So, what you could do is, if it belonged to both of them, it was 12,300 E to the power of 0.073, then I could move it to the front. But you understand my problem? It's only a power to the E part, it's not a power to the 12,300 part.
The brackets are actually around the E.
It's not so much the brackets are around the E as the power belongs to the E. It doesn't belong to the 12, what?
How do you know it doesn't belong to
Because there'd have to be a bracket, like that, okay? Now, there's two ways out of this, okay? The first thing we could do is you could do the addition rule, and you could break it up like this if you wanted. And do you understand what I did there? It's basically this one multiplied by this one. That's basically x and y. Remember, it's ln x plus ln y. So that's the addition rule. You could have done that, but there's actually no need to even go there in the first place. And then you could bring it over to the other side, take it away from the 20,000, and you get 20,000 divided by 12,300. But why do that in the first place? Like, you're just after making yourself a lot of work. So what I said is, what you're best to do at the very beginning is do this. Just bring whatever number is in front of the E downwards, and you're going to get 20,000 divided by 12,300, and then you're going to have E to the power of 0.073t. The power only belongs to the E now. There is no disputing that the power belongs to the E. Now we can ln both sides, and now we can undergo our power rules, okay? And the power rule is bring the power to the front. So we're going to have 0.073t ln E, and that equals ln 20,000 over 12,300. Now, what did we say about ln E? Same thing as log e to the base e. It is 1. Get t on its own. What do I need to do? So divide ln 20,000. Now, there's no need to find out what this is yet. Just leave it to the very end. It means you're not rounding off, and therefore you're not likely to make any errors. 0.073. And now just put it all into calculator. You could do it in you could do it in one step if you wanted. I suppose you could press the fraction button right away, then press the second fraction button, and we could do it all in one go. Or you could do it in 2 goes using the answer key. It's all the same. And just to make sure that doesn't happen to you, here we go. And on the bottom is 0.073. 6.66, okay? Now 6.66 is basically 6.7 years. So the answer is it takes 6.7 years to go up that far.
Could you solve the E to the power?
The population growth of a certain city with current population of 27,345 is modeled by the equation P equals 27,345 multiplied by e to the power of 0.005t, where P is the population of the city after t years and 0.005 is the rate of growth. What would be the population of the city 10 years from now? Okay, population equals 27,345. I want to find out what P is when t equals 10. That means anywhere I see t, replace it with 10. And it's actually just a calculator just put it straight into the calculator and see what you get. Okay, so 27,345. E being this one here. So what's it? 0.005 multiplied by 10, or bracket 10, whichever one you wanted. 28,747 people. So 28,747. So look, that's not too bad at all, is it? Just use the equation. Number 2. After how many years will the city's population reach 32,000? Which letter does the 32,000 stand for? Huh? P. Okay, replace P with 32,000. Okay, I'm going to do it Simon's way this time. Simon just asked me a slight variation on it, and I want to show you that it doesn't make a difference, okay? So 32,000 equals 27,345 e to the power of 0.005 t. Now, what the first step is going to stay the same, no matter what. Okay. Now, when I put that into my calculator and I put I'll do it out again. 32,000 divided by 27,345, and what I get is 6,400 divided by 5469. Which is more accurate, that or that? Fraction is always, fraction doesn't need to be rounded off. Well, decimals are always rounded off. So
we're going to round off your decimal.
Don't round it off until the end. If you can keep it in fractions, do so. You'll get a better answer. Okay, so fractions are not rounded off. Well, you're not going to write down all of that. But what you will write is 6,400 divided by 5469. Alright, that's not too bad. Right, so 6,400 divided by 5469. Okay, now that's, once we've done that, that equals, I'm going to leave a space in here on purpose. What's my next step? I need to isolate the t from the power position.
So add an ln, solve the t to 0.
Add an ln, add another ln, and figure out. Now, there's going to be a question asked here. Can I take the t out and just leave the 0.05 behind? How? Alright, there's a way of figuring that out. You can actually figure it out using your calculator, whether you're allowed to do it or not. Right, so I'll show you an example, alright? Ln e to the power of 10. Okay? I can check that out quite easily, can't I? What is the answer to that? It's 10, isn't it? By the power rule. So we know this is 10. Now, if I change this into two separate parts, a 2 and a 5, for instance, yeah? In the same way that this is consisted of two different parts. And by the same logic, if I took the 2 out on its own, it'd be 2 times ln e to the power of 5. If that also equals 10, then there's nothing wrong with what you suggested. Do you see my logic in that? Yeah. And you can check that using your calculator. Alright, so this is the way I used to remember stuff. So now I'm going to write that down. I'm going to write down 2 times ln e. Where's e to the power of 5? Shift e to the power of 5. You'll quickly do this in a test maybe just to verify what you're doing doesn't break any laws. It's also 10, which means it's fair game. Okay? Back to this now, okay? So what we've proved is that we usually move the full thing, don't we? We usually move the 0.05 and the t to the front. I'm just explaining to you that in a test, if you're to only move the t to the front, it still wouldn't affect the results. So what we're going to get here is just going to take the t alone to the front, and we still have e 0.005. And what Simon was saying earlier was, I can still get this in my calculator. So there's no problem there. So what I'm just going to do this time around is, I'm going to get ln 6,400 5469 divided by, we're going to get rid of that ln e, aren't we? So it's going to be divided by ln e to the power of 0.005. It's pretty much like for like, but we'll see what happens when we put it into the calculator, okay?
Could you just move down to 0.005 because you know that ln e is 1?
Oh yeah. You could do. but then you're doing exactly the same thing I'm doing. So there's no point really, is there?
It's all the same.
It's all the same way, exactly. So look, we'll just follow this through now. 6,400 divided by 5469, and if you were to happen to forget that ln e is in fact 1, there's always the calculator. I'll just do it divided. So we're doing ln e to the power of 0.005, and then close this bracket here, and it should turn out to be 31.44. Yeah, there we go, same deal. Okay, t equals 31.44. Okay, so going to do is number 1, I'm going to write down, it says the amount of radioactive decay tracer after t days is given by, so this is the amount, this is a number, a is a number, okay? So example is, in radioactive decay, something gives off 12,000 units of radiation. As an object gives out more and more radiation, okay, it goes down, so maybe a couple of hours later, it's only at 10,000, okay? So that's what happens with radioactive substances. It's like beep, 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 beep. Then a day later, it's just like beep, beep, beep. It's not as active, okay? So that's what this is all about. Big number at the start, and as time goes on, the number gets smaller, okay? Now, what's happening here is A0 is the original number. So it could be a big number like 20,000, okay? Now it goes, A0 is the starting amount at the beginning of the time period. After how many days to the nearest day will it take for 1/2 of the original amount to decay? For example, if we had 20,000 at the start, we're then looking for how much time does it take us to go down to 10,000. Because we don't know the number, what we can do here is we can say, okay, the original amount is A0. The amount that we're looking for is half of A0. Would you agree with that?
Yeah.
Because it's half the original amount. So A equals a half of A0. Okay, because that's the current amount needs to be half the original amount. Okay, so part 1 is setting up your equation. Set up equation. So setting up your equation varies from question to question, okay? So in this question it's going to be this. Half of A0, which is A, equals A0, lads, A0 e to the power of minus 0.058t. Stop there. Okay? Part 2. Bring the number that's in front of the exponential over to the other side. Okay? So bring over number in front of. We do this every time. Okay? Bring it over the number that's in front of E. So now we're going to divide a half A0 by A0. What's a half A0 divided by A0? A half. Or it's the same thing as a half X divided by X, which is still a half. Okay? So we now know that this equals a half. Okay? Now the next problem is, part 3 is variable that you're looking for. In this case it's T. T is in power position. Do you know what I mean by the power position?
Yeah.
It's the small number above it. To get rid of this, use ln use ln on both sides. Now, why do I use ln and not log base 10? I'm trying to get rid of the e, and the only thing that gets rid of an e is the base e. If that's base 10, that doesn't equal 1 because the base isn't the same as e. So that's why we specifically use log ln for these questions. Okay. Now that that's done, we're going to ln both sides and repeat the same step. So we're going to get ln a half equals ln e to 0.058t. What's the next step? Use log power rule. And the log power rule brings the t to the front. Okay? So step 3, use log power rule. Bring the power to the front, and what we're going to get is minus 0.058t ln e equals ln a half. Next step is ln e equals 1. It's not so much a step as it is part of the last step. And finally, isolate t. How do we isolate t in this case? Divide by minus 0.058. What do you know about time, by the way, lads? What can you tell me about time? It always has to be positive. And if it doesn't come out as positive, you've done something wrong. Okay? That does come out as a positive. I think it comes out as... I haven't got it here anymore. Just put that into the calculator. It's going to be ln a half divided by ln a half divided by minus 0.058. 11.95 years. Next thing, is there any specific instructions on how I should present my answer? Nearest year. Nearest day. Sorry, it's not years, it's days. Excuse me. Okay, so it's going to be 12 days. And that is the 4 steps that all the questions follow.
Can we see that?